Hello class, this is Geometry, topic 4-4 on tangents. Now we talked about tangents briefly back during 4-1. We're going to be going over them again more in depth here for 4-4. So the tangent is a line that intersects a circle at exactly one point. So my tangent would be line xt. The point of tangency would be at point T. Now the point in our interior would be either P or I. Actually, I'm not going to write or, we're going to write and. Okay. And a point in the exterior would be X. Now this, if you couldn't remember, is circle P, because P is the center. So, that's example 1, just a review of what a tangent is. Well, now we have a theorem that we're going to use. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So here we have circle C. Because AB is tangent and CB is a radius, I know that this is a right angle. And since this is a right angle, I can figure out, using Pythagorean theorem, the length of CA. So CA equals, when you find out what CA is, so A squared plus B squared equals C squared. 5 squared plus 12 squared equals C squared. Five squared plus 12 squared is 169, which means that C is 13. So CA will be 13. So the whole thing is 13. Now, we didn't want to know the length of CA. We want to find how long X is. Well, from C to the circle would be 5. So if I do 13 minus 5, I get that X equals 8. And so that's example number 2. Let's go ahead and take a look at example number 3. All right, so circle C, we have a tangent at AB. It says that DE is 16. EB is 9. And we want to find out what AB is. Well, we've been told that this is a tangent. Since this is a radius, that must mean that this is a right angle. Because the whole thing is 16, that means our radius must be 8. And now we need to figure out the three sides. Well, CB would equal 8 plus 9, which is 17. So now we have a right triangle where my height is 8, my base is 17, and I'm trying to figure out what X is. So 8 squared plus 17 squared equals C squared. So we get that 353 equals C squared. Take the square root of 353. And we don't get an exact number. So we can write the square root of 353. And that's approximately 18.79. I would accept either answer here because this is not an exact answer. We could round it and get this, or preferably we'll just leave it as the exact answer. Let's go ahead and move on. Here we have another theorem. If two segments from the same exterior point are tangent to a circle, then they are congruent. So that means that QP is equal to PR. So 2x minus 3 equals 27. Add 3 to both sides. 2x equals 30, which means that x equals 15. Simple enough. Let's go ahead and put that to practice in example number 5. So we want to find all of our indicated values. Well, first off, we want to find x. So if this is 2x minus 13, and this one is 48, we set those equal to each other. So 2x minus 13 equals 48. This is using the theorem from example number 4. I add 13 to both sides. I get that 2x equals 61. We divide by 2, and we get that x equals 30.5. All right, well, for ABC, well, this is a tangent, this is a radius, which means that this is a right angle, so it is 90 degrees. And now we want to figure out what BC is. We want to figure out what the radius is. Well, I have a right triangle, so I'm going to go ahead and call this R. My hypotenuse is the 52. And we know that this is 48, because it's the same as this. So, 48 squared plus R squared equals 52 squared. We subtract 48 squared from both sides. We get that R squared equals 400, which means that R equals 20, because the square root of 400 is 20. So that means that BC is 20. Now, if our radius is 20, then our diameter would be 2 times that, so our diameter is 40. So, for x, we use the theorem from example 4. The measure of angle ABC, we use the theorem from the earlier examples, examples 2 and 3. We use that same information, a Pythagorean theorem, to find our radius, and then twice the radius is the diameter. Let's go ahead and answer the last one. When circles are inscribed in polygons, the polygons are said to be circumscribed polygons. In such polygon, each side is tangent to the circle. So here we have a triangle that is circumscribed about A. If the perimeter is 50, and TK is 3, and WM is 9.5, we want to find TR. Well, if this is 3, that means that this must also be 3. And this is 9.5, that means this must also be 9.5. And so now we just have to figure out what's left. Well, that means this whole side, 9.5, well, basically, if I add everything together, I should get my perimeter of 50. So I'm going to call these x, because I know they are also the same side. So that means that 3 plus x plus 9.5 plus 9.5 all has to equal 50. So this means that 25 plus 2x equals 50. So 2x must be 25. So x must be 25 divided by 2 is 12.5. So this is 12.5. Now, I wanted to find TR. So if I take 12.5 plus 3, I get 15.5. Moving on to the last page. Example number 7. We want to find the perimeter of this shape. Well, I know if that is 2, then this is 2. If this is 3, then this is 3. If this is 1, then this is 1. And if this is 3, then this is 3. Okay? So, I just simply add that all together. 3 plus 2 plus 2 plus 3 plus 3 plus 1 plus 1 plus 3. And I get 18. That one was really simple. Now for example number 8. Given that OA is 12, OB is 6, and BAC is 60 degrees, we want to find all the following. Well, OC is another radius, and my radius was 6, so this one's also 6. ED is the diameter. Well, 6 times 2 is 12. AB, well, I know that this is a right angle because of the point of tangency. So 6 squared plus a squared equals 12 squared. If I subtract 6 squared from both sides, I get 12 squared minus 6 squared is 108. And the square root of 108 is roughly 10.39. I'm going to go ahead and put the square root of 108 is roughly 10.39. AC is going to be the same length as AB, so it is the same thing. These two sides are going to be the same. Angle BAO, well, if this was 60, that means that, and I cut it in half right here, so that means that it must be 30 degrees. OCA is 90 because of the point of tangency. AOC, well, if this is 30, and that's 90, then this must be 60. EOC, well, that's the same as AOC. And then the length of EA, well, if my radius is 6, and EA is 12, 12 minus 6 is just 6. So, putting a lot of information together to find all the missing pieces. It's really not that complicated. It's just a matter of remembering your two theorems and some basic things about circles and right triangles. Good luck on your assignment, and have a good day.